Hello students, in the today's lecture we are going to study numericals based on pH scale. Hello students, in the today's lecture we are going to solve numericals based on pH scale. So our first numerical is calculate the pH and the pOH of 0.001 molar HCl solution. So here in the solution, what is the given? The concentration of HCl is equal to 0.001 molar. So, since HCl is strong acid, it completely dissociate. Strong acid and strong base gets completely dissociates. So therefore, the concentration of H plus ion will be equal to 0.001 molar. Why? Because the HCl is strong acid and it gets completely dissociate into H plus ion and Cl minus ion. So whatever the concentration of HCl is there, that much will be the concentration of H plus ion. So we know that pH is equal to negative logarithm to the base 10 concentration of H plus ion. Okay. So now minus log of concentration of H plus ion is 0.001. This comes to be equal to minus log of 0.001 is 3 or it is minus 3. So this minus will become plus. So pH is equal to 3. Okay. So what is asked? You have to find pOH. We know that pH plus pOH is equal to 14. Therefore, pOH is equal to 14 minus pH, which is equal to 14 minus 3. So, pOH is equal to 11. Okay. The next question is calculate the hydrogen ion concentration of a solution whose pOH is 8.6. So, in the solution, we will write the given. Given is pOH is equal to 8.6. Okay. We know that pH plus pOH is equal to 14. Okay. Therefore, pH is equal to 14 minus pOH. Okay. So, 14 minus 8.6. Which is come 5.4. So the pH is equal to 5.4. What we have asked? Calculate the hydrogen ion concentration. That means you have to find concentration of H plus. So here we know that pH is equal to minus log of concentration of H plus ion. Okay. So we have to find the concentration of H plus ion. So first we will take this negative side to this side. So log of H plus ion concentration is equal to minus pH. So when we shift log from left hand side to right hand side, it converts into antilog. So concentration of H plus is equal to antilog of minus pH. Okay. So now we will find the antilog of minus pH value is 5.4. Okay. So in the examination, the calci is allowed to you. So first I will show you how to calculate the antilog on the calci. I think you are able to see the calci. Okay. So when you have to find the antilog, you have to press the shift and then log. And into bracket minus 5.4 bracket close, which is equal to 3.981 into 10 raised to minus 6. So when you have to find the antilog, you have to press shift log. Okay. So the concentration of H plus ion is equal to 3.981 into 10 raised to minus 6. The unit of concentration is mole per liter. Okay. You have to remember the units of concentration, that is mole per liter, and in the examination there is half marks for writing the unit. Okay. So the next question is the degree of ionization of 0.1 molar monobasic weak acid is 0.130. Calculate the pH of solution and pKa of monobasic weak acid. Okay. So here what we will do, first of all we will write the given things. Okay. So what is given? Degree of ionization of 0.1 molar monobasic weak acid. So that means concentration of weak acid is given. Concentration is denoted by small c, which is equal to 0.1 molar. Okay. The next thing, the degree of ionization is 0.130. Degree of ionization is denoted by alpha, that we have seen in the previous lectures. Okay. 0.130. So now we know that alpha is equal to number of molecules ionized or dissociated upon total number of molecules. Okay. So alpha we know, total number of molecules, that means concentration. So alpha, total number of molecule is C. So number of molecules ionized or dissociated. So in the question itself, that is given monobasic weak acid. Monobasic means the one which gives only one H plus ion on the dissociation. That means we will take an example that HCl is there. Hi. This gives only one H plus ion on the dissociation. So these are called as a monobasic weak acids. Okay. So that means number of molecule ionized or dissociated. That we don't know. So here we can take the concentration of H plus. So from here the concentration of H plus will be equal to alpha into C. Okay. So alpha is 0.130 into concentration is 0.1. This calculation comes to be equal to 0.013. Okay. This is the concentration of H plus ion. Is it okay? And it is half the unit mole per liter. Okay. So now we know that pH is equal to minus log of concentration of H plus ion. So minus log of 0.013 is equal to 1.886. Okay. This is the value of pH. Okay. This is the value of pH. And what we have asked, calculate the pH of solution and pKa of monobasic weak acid. So now we know that Ka, that is ionization constant of weak acid, is equal to C alpha square upon 1 minus alpha. We know the value of C and we also know the value of alpha. So we can calculate this. The value of C is 0.1 into 0.130 square upon 1 minus 0.13. So now this calculation comes to be equal to 0.0169 upon this subtraction is 0.87 and this division is equal to 0.00194. But we have asked to find pKa, not Ka. So pKa is equal to minus log of Ka. That means minus log of 0.00194, which is equal to minus into minus 2.712. So this minus is plus 2.712. So the value of pKa is 2.712. Okay. In this type of numerical, you have to remember that you have not asked Ka. You have to find pKa. Many times what happen? The student thinks that you have to find Ka and it stops there. But it is not like that. You have to find the pKa value. Okay. The next numerical is the pH of 0.05 molar ammonium hydroxide is 9.95. Calculates its ionization constant and pKb. So in this numerical we will write first the given things. Given the pH of, so the pH is given. pH is equal to 9.95. Okay. The pH of 0.005 molar. That means the concentration is also given. That is 0.005 molar. Okay. What we have to find? Ionization constant for the weak base. That is Kb. You have to find. And also pKb you have to find. Okay. So now we know that for finding the Kb is equal to C alpha square upon 1 minus alpha. So for finding the Kb, we have the value of C, but we don't know the value of degree of ionization. Okay. So how we can find the value of alpha? So we know that pH plus pOH is equal to 14. Okay. And therefore pOH is equal to 14 minus pH. So 14 minus 9.95, which is equal to 4.05. Okay. pOH is equal to 4.05. We know that pOH is equal to minus log of concentration of OH minus. Okay. Now to find the concentration of OH minus, we know it is equal to antilog of minus pOH. Similar to the example second or the problem second. Okay. So antilog of minus 4.05 and which is equal to 8.91 into 10 raised to minus 5 mole per liter. Okay. So now we have the value of OH minus. We know that alpha is equal to number of molecules ionized or dissociated upon total number of molecules. So here there is ammonium hydroxide, which is a weak base which does not get completely dissociated. And ammonium hydroxide is which gives only one OH minus ion upon C. So the concentration of OH minus we know, C also we know. So it is 8.91 into 10 raised to minus 5 upon concentration is 0.005. So alpha is equal to 1782 into 10 raised to minus 5. So now what we will do, we will shift this decimal. So when we shift this decimal to like this, we are decreasing the value. So therefore 10 raised to minus 5. So we have shifted this decimal by 1, 2, 3. 3 places. So add there 3. So when we shift the decimal point to left, we add the number of digits. Okay. And when we shift it to the right, we subtract that. So 1.782 into 10 raised to minus 2. Okay. Or we can also merge this as 0.01782. Okay. So this is the value of alpha. Now KB is equal to C alpha square upon 1 minus alpha. Putting the values, concentration is 0.005 into alpha is 0.01782 bracket square upon 1 minus 0.01782. And this whole calculation comes to be equal to 9.79 into 10 raised to minus 7. Okay. Now PKB is equal to minus log of KB. So minus log of 9.79 into 10 raised to minus 7 is equal to 6.009. So this is the value of KB. Okay. So this was 4 numericals which are based on pH scale. Okay. We will stop here. Thank you.